Kia ora and welcome to day 2 of the holidays. Today we're just going to do 2 trig questions because they're quite long and yesterday's video was long enough. So the first one is to solve this equation and we're looking for theta between 0 and 2 pi. So having a look at that, just notice that we've got sine of something else and sine of something else. But it's not sine of theta, so we have to somehow manipulate it to get something solvable. So your clue for that one is the sum to product rules. The next one is just the trig identity to prove that the left hand side equals the right hand side. There are a couple of different ways to do that one. There's not really much hard trig in it, but it gets a little bit messy. So pause the video and have a go at both of those, and then I will go through them. Okay, so our first one is this. So we want to solve sine of 3 theta plus sine of 2 theta plus sine of theta equals 0. Now, usually when we're solving equations, the best way to do it is to get something times something equals 0. And that's what we're going to do here. So we're going to do the sum to product rules. We're going to remember that if I've got sine of an angle, so sine of P plus sine of Q is equal to 2, and then it's sine, half the sum, times cos of half, oh, what's happened to my pen? Half the diff. Let's just see what's going on with the silly iPad. There we go, that's better. Okay, so now we have to decide, well, what are we going to do that on? We're not going to do it on all 3, but we might try to do it on just 2 of the terms in here. And looking at it, the more you do, the more you'll get a feel for which ones to pick. But the sine of 2 theta is in the middle, so we might try playing around with sine of 3 theta plus sine of theta, and we'll just let the sine of 2 theta sit there. So this is what we're going to get. So we've got sine of 3 theta plus sine of theta plus sine of 2 theta equals 0. Now putting these together, we're going to get this 2 sine, right, half the sum. So that's 3 theta plus theta over 2 times cos of half the difference. So 3 theta minus theta over 2 plus sine of 2 theta equals 0. So why am I happy with that? Well, looking a little bit down the track, I've got a sine of 2 theta here, and I can see that I'm going to have 2 theta here. So that's going to give me a common factor that we can take out. So working through that, we've now got 2 sine of, well, 4 theta over 2 is 2 theta. Cos 2 theta over 2 is just cos of theta, plus sine 2 theta equals 0. So we've gone from something pretty awful up here to something really nice and easy here. We've got a common factor of sine 2 theta, so we'll take that out. Sine of 2 theta times 2 cos theta plus 1 equals 0. And remember, we're looking for theta between 0 and 2 pi. Now, to give you some general solutions practice, I'm going to do one bit of this with general solutions, the sine of 2 theta, and I'm going to do this bit with my circular diagram. Okay, so just working with it on that. I'm going to do that on a new slide. So again, pause the video, try and go from here. We're looking for all of the solutions between 0 and 2 pi. Right, so first, let's solve sine of 2 theta is equal to 0. So alpha, my principal value, is sine inverse of 0, which of course is just 0. So now I have this. 2 theta is equal to n pi plus my switch function, so negative 1 to the power of n, times alpha, which is 0. So in this case, my general solution comes out to be theta is equal to n pi divided by 2. Because this is always 0. Right, so that goes. So that's telling me that in the range of values that we want, theta is equal to 0 pi on 2, pi, 3 pi on 2, and 2 pi. Right, so that's that one. Now, we either have sine of 2 theta equals 0, or we have 2 cos theta plus 1 equals 0. That gives me cos theta is equal to negative 1/2. So lots of ways to do this. You can do this using general solutions as well. Remember, this is my trig graph, but the one that is better in some ways here is to think about cos of theta is equal to x over r. So when is x over r going to equal negative 1/2? Well, we'll have an x of negative 1 and an r of 2. So we recognise that's a special triangle. So for that to happen, the angle there is 2 pi on 3. Or, down here, negative 1 over 2 gives me negative 2 pi on 3. Negative 2 pi on 3 is the same angle as, well, leads me to the same place as 4 pi on 3. Okay, so I've got two solutions to this factor in my range of values, 2 pi on 3 and 4 pi on 3. Now if you wanted to get there using general solutions, it would look like this. Alpha is equal to 2 pi on 3. So theta is equal to 2n pi plus or minus alpha, which is 2 pi on 3. So if we substitute n equals 1, that gives me 2 pi minus 2 pi on 3, which is 4 pi on 3. It also gives me 8 pi on 3, which is not in my range. Okay, and if we substitute n equals 0, one of the values we get is 2 pi on 3. So that's all a bit messy. What we want to do to finish it off is to write down the full set of solutions over here, and it's nice to do that in order. So we get the solutions are theta is 0, pi on 2, 2 pi on 3, pi, 3 pi on 2, 4 pi on 3, and 2 pi. Okay, so that's that one done. Now the next one is the identity, and there are a couple of different ways to do that. Right, so we're trying to prove this, that 1 minus sec theta squared minus 1 minus cos theta squared is always equal to tan theta minus sine theta squared. Now we can expand that out, expanding out the left hand side, and go as far as I can. So we can do this, and then we can do the same thing on this side and get them equaling each other. And that works. But I'm not going to do that way. I'm going to show you a slightly nicer way, which is the difference of two squares. So we'll start on the left hand side, and we recognise that here we've got something squared minus something else squared. We want to keep one eye on where we're going, so we're looking to get tans and sines coming out, and that will happen quite quickly. So 1 minus sec theta squared minus 1 minus cos theta squared can be written like this. 1 minus sec theta plus 1 minus cos theta times 1 minus sec theta minus 1 minus cos theta, which gives me, what have we got? Well, we've got 2, so this looks a bit yuck, 2 minus sec theta minus cos theta, but then the next term is just cos theta minus sec theta. So if I expand this out, then I'm going to commit the sin of moving my equal sign, which doesn't look very nice, but it works better. So 2 cos theta minus. Okay, sorry, I've had hiccups with the sound here, but hopefully it's working again now. So we're just going to expand this out. So 2 cos theta minus 2 sec theta minus sec theta cos theta plus sec squared theta minus cos squared theta plus sec theta cos theta. And you can see that some of this is going to knock itself out, so we'll clean it up down here. We get 2 cos theta minus 2 sec theta plus sec squared theta minus cos squared theta. Right, now we need to look where we're going, and we're going towards tan theta minus sine theta squared. So we're getting somewhere, but we don't have tan and sine, we have sec squared and cos squared. We're going to use the Pythagoras identities to flip those over to what we want. So pause and do that now. I'm going to try and resurrect the next 2 slides of video, which have recorded with no sound. So we'll see how that goes. Okay, so where have we got to? Well, we've got the line on the last page. We're going to replace the sec squared theta and the cos squared theta with their tan and sine squared equivalents. So we get 2 cos theta minus 2 sec theta plus 1 plus tan squared theta minus 1 minus sine squared theta. What does that give me? Well, it's nice. I get to this 2 cos theta minus 2 sec theta plus tan squared theta plus sine squared theta. Now if you think about where we're going, we want to end up with tan theta minus sine theta squared, right? So put that in a little box out the side. So you can see that's starting to work. We've got the tan squared theta and we've got the sine squared theta. All we have to do is manipulate this to get the middle term. So that's what I'm going to do now. Just make sure you do it step by step without too many leaps of logic, because proofs are all about following through. So here we're going to have 2 cos theta minus 2 over cos theta plus tan squared theta plus sine squared theta. I'm just going to erase that, get rid of that, because that's where we're going. Now here, what have we got? Well, we've got 2 cos squared theta minus 2 plus tan squared theta plus sine squared theta. So this is equal to, we want to have a minus in there, so we're going to have minus 2 minus 2 cos squared theta over cos theta plus tan squared theta plus sine squared theta, which is equal to negative 2, and 1 minus cos squared theta is sine squared theta. So we're getting very close now. There we go. One more slide to finish it off. So negative 2, the sine squared over cos theta is equal to tan theta sine theta. And that gives me what I'm after, which is tan theta minus sine theta squared as required. So we should really write equals right hand side as required. So there we go. Thanks for watching. Sorry about the glitches with the sound, and let me know if there's any big problems with the video.